Hello folks, welcome back to another video. So today we're going to talk about the next section, which now that we've introduced rational numbers, it will be to add rational numbers. So how do we deal with operations with these things? So to add rational numbers in fraction form, we must have a common denominator. So what that means is that the denominator of my fractions must look the same in order to add them. And again, I'll come back to this definition that we used in the first video, was that if this bottom number is the type of step that we're taking, and this top number is how many of those steps, well, in order to be able to add these things, in order to be able to compare them, it is worthwhile to have similar sized steps, right? So if I have two steps of 1/3, right, and then one step of a fifth, it's hard to say, okay, well then how many total steps is that? So what we're going to want to do is change this 3 and change this 5 into something that is comparable, right? So we have kind of three strategies that we can use in order to change those. So strategy number 1, or plan A, is to just multiply the denominators, right? So if I take 3 and I multiply it by 5, I get 15, right? But then, so that 15 is something that we can use as our new denominator, right? We can take this and turn it into something that is, instead of being over 3, will be over 15. And then do the same thing for this one. Instead of being over 5, can be over 15. But the problem with that is when we do it like that, it's not always going to be the smallest number. And usually when we're talking about rational numbers, is we want to work with the smallest possible fraction, right? So I don't like 3 over 6. I'd much rather that be 1 over 2, and so on and so on, right? So whenever we have something that is simplifiable, we want to make sure that it is simplified. So then plan B, on the other hand, is to find the lowest common multiple. And there's a number of ways of doing that, but the simplest way is to just list all the multiples of 3 and list all the multiples of 5 until you find one that they have in common. So 3 would be 3, 6, 9, 12, 15, 18, 21, and so on and so on. And 5 would be 5, 10, 15, 20, 25. And then what we notice is that both of these lists have a 15. So we would say that the least common multiple of 3 and 5 is 15. So then that's how we know that 15 is the number that we'd like to use. Okay, so the other strategy, and one that just takes a bit more memorization, is if you had something like a least common multiple cheat sheet, right? If you made yourself a little table like this where each of these boxes, so the least common multiple of 2 and 2 is 2, well, the least common multiple of 2 and 3 is 6. The least common multiple of 2 and 4 you might think would be 8, but it's actually 4, right? So it doesn't always work to just multiply the numbers to find this common denominator. Sometimes we want numbers that are smaller than that. So in that case, we'd have 4, and then 2 and 5 would be 10, and 2 and 6 would be 6, and 2 and 7 would be 14, and 2 and 8 would be 8, and then 18, and finally 10. Right, so feel free to copy this table down, pause the video, and copy it down, and fill it in for yourself, right? And once you have it filled in, then you'll have this little cheat sheet to kind of look back on. Okay, well, what that means is we're going to have to use either plan A or plan B here to find our common denominator. So we already decided that it's going to be 15, right? So then what we need to do is we need to figure out, well, how does a 3 turn into a 15? Well, it does it by being multiplied by 5. So that means that the 2 has to also get multiplied by 5. And we talked about equivalent fractions in the first video, right? That 1 over 2 being in the same position as 2 over 4, right? Those are equivalent fractions. Well, these are equivalent fractions as well. 2 over 3 is equivalent to 10 over 15. And if you plug 2 over 3 into your calculator, you would get 0.6 repeating. And if you did the same thing, 10 divided by 15, you would also get 0.6 repeating, right? It doesn't change its value. So that's really important. That's the key thing here. So if I'm going to multiply the 3 by 5, I also have to multiply the 2 by 5, and I'll get the equivalent fraction 10 over 15. And then if I do the same thing with the 1 over 5, right? So 5 times 3 is how I get 15. So that means 1 times 3 gives me 3. So now, in order to add these things, if 2 over 3 was 10 over 15, and 1 over 5 was 3 over 15, now what you'll notice is that my steps, right, these bottom parts here, they're the same. They're both 15s. So that means that the top parts are now comparable. If I had take 10 steps of this size and 3 steps of this size, in total I have taken 13 steps of that size. So my final answer here would be 13 over 15. All right, let's do another one. Ooh, this time we have a negative. Well, negative rational numbers work very similarly to negative whole numbers, right? So what's going to happen is when I add a negative number, that turns into a subtraction. So this thing could be rewritten as 2 over 3 minus 1 over 5. And again, what we'd need to do that is we would need to have comparable size steps, right? Comparable denominators. So that's 10 over 15 minus 3 over 15, and we get 7/15. Okay. Now, sometimes we might see something called a mixed fraction, right? So what we need to do is, in order to take those mixed numbers, we want to be able to add them and subtract them, but they don't really subtract or add very nicely when they're in this form. So what we want to do is we want to be able to take something like that and turn it into what we call an improper fraction, where sometimes we don't like that numbers in the numerator are bigger than numbers in the denominator. So those are called improper fractions. So we use mixed numbers to represent those. But these mixed numbers are not as easy to add with. So what we can do is we can take this and we can turn it into, well, this is 2 whole, right? So this is just the number 2 plus another 6th. Right? And then again, because 2 is actually 2 over 1, we're really just adding fractions again, right? What is the common denominator here? Well, the common denominator is going to be 6, right? So how do I turn a 1 into a 6? Well, I multiply it by 6, right? And then what do I have to do to the 2? Well, I also need to multiply that by 6, and I get 12. So 12 over 6 plus 1 over 6 is 13 over 6, right? 2 times 6 plus 1 gives us the 13 over 6. All right, so then if I wanted to then use this, right, so the negative 1/4 plus, well, this is hard to add, but it's so much easier to add that 13 over 6. So now what I need to do is, again, find that common denominator. So in this case, my common denominator would be 12. And again, how do I turn a 4 into a 12? Well, I multiply it by 3. So that means I need to take this negative 1 and multiply that by 3, and I get negative 3. How do I turn a 6 into a 12? Well, I multiply it by 2. Right, so then what do I do with this 13? I need to also multiply that by 2. So 26 over 12. So now, because my denominators are the same, I could just add the numerator. So 26 and negative 3. So negative 3 plus 26 gives me 23 over 12. And then if I wanted to take that and convert it back into a mixed number, what we're trying to do here is we ask ourselves, well, how many times does 12 go into 23? Well, it goes into 23 one time. And then if I were to take a 12 away from 23, I'm left with 11 as my remainder. So 1 and 11/12 would be the mixed number, right? So this is my mixed number, right? And this one, again, is an improper fraction. So the last thing we have to think about is decimals. How do we add decimals, right? Because these are also rational numbers. And I find that there's a couple of ways of dealing with a question like this. You could think about it like the fraction, right? Because these things can be made up as fractions. But most people are just going to want to deal with the decimal. And in order to subtract decimals, I find the easiest way to do it is to think about them like the whole numbers, right? So this is negative 3.1. And just for a moment, let's consider that negative 31. And this is positive 1.2. So again, just for a moment, let's consider that positive 12, right? So if I wanted to add negative 31 plus 12, well, we could do that in a couple of different ways. And whatever strategy you think best works best for you, great. But when we do that, we get negative 19, right? But obviously, negative 3.1 and 1.2 is not 31 and 12. It's negative 3.1 and 1.2, so our answer ends up being negative 1.9, right? So that's probably the easiest way to deal with a question like this, is to think about them like the whole numbers. But there's all kinds of different strategies that we can use. And I think really the big takeaway from this lesson is how to deal with the fractions. All right, so that is it for today's video, and I will see you in the next one.